5.2 Accuracy. In everyday life, people often use the words precision and accuracy to mean the same thing. In mathematics and in trades, however, they have unique meanings. Accuracy refers to the exactness of the measurement. Have you measured this the correct length? Can you repeat that measurement? Can somebody else take that same object and get the same measurement? Precision refers to the number of digits being measured. So this is talking about the device being used. Does this device measure to centimeters, to meters, to millimeters? So accuracy is about performing the measurement. Precision is about the device being used. We'll talk about precision in a future lesson. To be accurate, a measured value must be close to the real value as possible. If you have measured something accurately, someone should repeat the same measurement and get the same value. Let's look at examples of accuracy and appropriateness. Explain if the following measurements would give you an accurate measurement, and if the measuring device is appropriate. Explain why or why not. So question A, using the length of your forearm to measure the length of a picnic table. Is it accurate? Again, can you repeat the measurement and get the same measurement? Can somebody else do it? Well, here we would say our accuracy is no. We cannot be accurate using our forearm. My forearm is different from your forearm. Is it appropriate? Well, it doesn't make sense to measure a picnic table with your forearm. You'd probably get a measurement between 5 and 6 forearms long. That seems fairly appropriate. So we would say yes, it is appropriate. Example B. Using the length of your stride, as you walk your stride, to mark off the playing field for soccer. Now, is it accurate? Well, again, we get back to the point that my stride is different every time. It might vary by up to an inch or so. Plus, my stride is different from your stride. So it is not accurate. So we would say no. Is it appropriate? Well, if you were to measure a soccer field with your stride, you'd probably get 100 strides by 60 strides. Does it make sense to mark off a soccer field in strides? Well, yes. So our appropriateness is yes. Example C. Using a meter stick to calculate the distance between two cities. Well, a meter stick never changes. It's always the exact same measurement. So if I repeat this 2 or 3 times, I should get very similar results. Also, if I give that meter stick to you, you should get a similar result to mine. So will it be accurate? For our purposes, we can say yes. But appropriate. Does it make sense to measure the distance between Winnipeg and Brandon, or Winnipeg and Portage using a meter stick? Well, no, it doesn't. You'd be there an awfully long time. So we can say that if we did it properly, we should be fairly accurate, but it's not appropriate to do. Example D. Using a ruler marked in millimeters to measure the width of a book. Well, accuracy. Again, the ruler doesn't change. So I can repeat this process 5, 6, 7 times. I should get very similar results. And you should get similar results using the same ruler. So we can say yes, it's appropriate. Now the width of a book. Books aren't very wide. So if we're marking in millimeters, that would make sense. So it's appropriate? Yes, it is. So when you're dealing with accuracy, ask yourself, can I repeat this and get the same measurement? Can somebody else get the same measurement? And does it make sense for me to measure this with this device? You'll notice for accuracy we had no for the first two. the length of our arm and the length of our stride. Those are not standardized measurements in any way. So accuracy is really talking about standardized measurements. The meter stick is standard. A meter is a meter is a meter. The ruler marked in millimeters is standard. A millimeter is a millimeter is a millimeter. So we can say for accuracy, we want standardized measurements. For appropriateness, does it make sense? Yes or no?